How to calculate rolling, moving average using Python plus NumPy, SciPy. There seems to be no function that simply calculates the moving average on NumPy/SciPy, leading to convoluted solutions. My question is twofold. What's the easiest way to, correctly, implement a moving average with NumPy? Since this seems non-trivial and error-prone, is there a good reason not to have the batteries included in this case?
A simple way to achieve this is by using np.convolve. The idea behind this is to leverage the way the discrete convolution is computed and use it to return a rolling mean. This can be done by convolving with a sequence of np.1s of a length equal to the sliding window length we want. In order to do so, we could define the following function. This function will be taking the convolution of the sequence x and a sequence of ones of length w. Note that the chosen mode is valid so that the convolution product is only given for points where the sequences overlap completely. Some examples. For a moving average with a window of length 2 we would have, and for a window of length 4. How does convolve work? Let's have a more in-depth look at the way the discrete convolution is being computed. The following function aims to replicate the way np.convolve is computing the output values, which, for the same example above, would also yield. So what is being done at each step is to take the inner product between the array of ones and the current window. In this case, the multiplication by np.1sw is superfluous given that we are directly taking the sum of the sequence. Below is an example of how the first outputs are computed so that it is a little clearer. Let's suppose we want a window of w equals 4. And the following output would be computed as and so on, returning a moving average of the sequence once all overlaps have been performed.
If you just want a straightforward non-weighted moving average, you can easily implement it with np.consum, which maybe is faster than FFT-based methods. Edit corrected and off by one wrong indexing spotted by being in the code. Edit. So I guess the answer is, it is really easy to implement, and maybe NumPy is already a little bloated with specialized functionality.
NumPy's lack of a particular domain-specific function is perhaps due to the core team's discipline and fidelity to NumPy's prime directive. Provide an n-dimensional array type, as well as functions for creating and indexing those arrays. Like many foundational objectives, this one is not small, and NumPy does it brilliantly. The much larger SciPy contains a much larger collection of domain-specific libraries, pulled subpackages by SciPy devs. For instance, numerical optimization, optimize, signal processing, signal, and integral calculus, integrate. My guess is that the function you are after is in at least one of the SciPy subpackages, SciPy.signal perhaps. However, I would look first in the collection of SciPy scikits, identify the relevant scikits and look for the function of interest there. Scikits are independently developed packages based on NumPy/SciPy and directed to a particular technical discipline, for example, scikits image, scikits learn, etc. Several of these were, in particular, the awesome OpenOpt for numerical optimization, were highly regarded, mature projects long before choosing to reside under the relatively new scikits rubric. The scikits homepage like to above lists about 30 such scikits, though at least several of those are no longer under active development. Following this advice would lead you to scikits timeseries. However, that package is no longer under active development. In effect, pandas has become, as far as I know, the de facto NumPy-based timeseries library. Pandas has several functions that can be used to calculate a moving average. The simplest of these is probably rolling_mean, which you use like so. Now, just call the function rolling_mean passing in the series object and a window size, which in my example below is 10 days. Verify that it worked. For example, compared values 10 to 15 in the original series versus the new series smoothed with rolling mean. The function rolling_mean, along with about a dozen or so other functions, are informally grouped in the pandas documentation under the rubric moving window functions. A second, related group of functions in pandas is referred to as exponentially weighted functions, for example, UMA, which calculates exponentially moving weighted average. The fact that this second group is not included in the first, moving window functions, is perhaps because the exponentially weighted transforms don't rely on a fixed length window.
Here are a variety of ways to do this, along with some benchmarks. The best methods are versions using optimized code from other libraries. The bottleneck.move_mean method is probably best all around. The SciPy.convolve approach is also very fast, extensible, and syntactically and conceptually simple, but doesn't scale well for very large window values. The NumPy.comSum method is good if you need a pure NumPy approach. Note, some of these, for example bottleneck.move_mean, are not centered and will shift your data. Timing, small window, n equals 3. Timing, large window, n equals 1001. 。 Memory, small window, n equals 3. Memory, large window, n equals 1001.